Hello and welcome to another one of D's ADD videos. Today we're going to look at some intermediate examples of exponential derivatives. Here we have 2 to the 3x. If you remember the rule for any number to whatever, you only tag on the natural log of that number. Everything else remains the same. You rewrite the number to the box and multiply it times the derivative of that box, whatever that box may be. So in this case, the box is 3x, and the number we're dealing with is 2. So we have ln of the number 2 times 2 to the 3x times the derivative of the exponent 3. So you can rewrite it then you can bring the exponent up to the, then you can bring the coefficient up, make it an exponent, bring the 2 to the x out front. Technically, you could just stop right here. This is an acceptable answer. If your professor or teacher requires you to simplify, and then at that point you can go further. Here, the big picture is we have 1x here, 1x there. They're multiplied together, so therefore we must use the product rule. So if I call this u, call this v, it's u prime v plus v prime u, excuse me, and then at this point when I derive u times v with no change plus the derivative of the v times u with no change. If you want, you could factor out, it looks like a 3 and a e to the 3x, leaving you a 3x squared plus 6x. I wrote them in reverse order just to have it descending powers. Again, this answer is acceptable if you're just being tested on derivatives and they don't require you to simplify using algebra. Here, 2 variables again. Now in this case, they're being divided. So I call this one v, I call this one u. Be u v prime minus v u prime over u squared. Low d high minus high d low over low squared. Take the derivative of anything that's following the d. But this is not a quotient rule video, this is an exponential derivative, so let's go ahead and do that. We've got the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Now if you're asked to simplify in this case, I would probably factor out the 6. There's an x, and then there's a e to the 2x. That would leave behind a 1 right there. Take all of this, divide by all of that. Take all of this, divide by all of that, and you'd be left with, looks like an x. Then you get e to the 4x because you have 1 power raised to the other power. Cancel the e to the 2x's, and that's your final answer in fully factored and simplified form. Okay? So they can get more challenging, more intricate. This is just trying to explain concepts of exponential derivatives. So I did a very basic product rule, a very basic quotient rule. They will get more difficult than that. You should also know how to take the derivative of a number raised to a power. All right? So practice, practice, practice. I hope I've eliminated any doubts that you might have. Thank you and have a nice day.